In this iterator example, we're going to take a look at how to have this red particle memorize a bunch of particles nearby and be able to iterate through all those guys he's memorized and have them do something. You can see here we've got a matter waves borning a bunch of blue particles on this plane. We've got a ParticleDraw borning this red particle. Let's go ahead and come out of the born rule, create a new rule, and we're going to kind of jump ahead and use an operator we haven't talked about yet. It's an initiator called PSearch. PSearch is going to allow us to either search in a radial distance either from a particle or a position. In this case we want a particle, so we're going to connect that, and we're going to go ahead, and the group that we want to search is the blue group. And right now we're just going to go ahead and create a simple group here where we're going to take all the particles that it finds in this radius and sends them out to a green group. So we're going to go ahead and take the Found PIDs, particle IDs, and pass them into the green group. So we can see that as we modify this radius, we're going to find more and more particles nearby. And it's also, we have the ability, we could output the count, density, average position, etc., all this information. But what we want to do is we want to actually have that red particle memorize and store in memory all these particles that he's found, or as many as he can. We're going to come here to the standard and into the memory, and we're going to add a new memory slot to memorize. We're going to memorize particles. We're going to call this nearby particles, and we're going to give it a depth of 99, which is the maximum. Oops, let's say enter there. And then what we're going to do is we're going to go ahead and expose this to the input, and we're going to go ahead and take all of these found PIDs and put them into memory. We don't actually want them to be in the green group anymore. This is just to use so we can see what's happening. We'll go ahead and disable that. So they stay in the blue group, but now we want the red particle to be the one who memorizes them. So this one red particle is storing a memory. He's got a memory array that's going to store 99, at least 99 particle values. If he only finds 5, it's only going to fill up 5. And the way this works with the found PIDs in memory is that because we're not specifying a depth, what's happening is it's taking each found PID and stuffing it into the 0 slot. And with each new one that it adds, it pushes the previous one down a slot. So it's going to fill up 0 through however many it finds. We could expose this found count if we wanted. We could do something like, remember that if you're going to use debug, you have to actually use the value somehow. So we're going to use found count into the size there. We're going to go ahead and say write to debug. Turn this on. So he finds 181. So this is going to exceed our memory count. We can only store in memory 99 values. So it's going to take the last 99 that he has found. Let's actually go ahead and decrease this radius, and we'll it's quite the breaking point there. Okay, so 98 particles within 22 units. Let's go ahead and turn off debug, and we'll turn off that size. We don't really need that. Write to debug log. Oh, just to point out as well, if you have multiple pieces of debug information being fed out from different areas, there's the new right-click menu has a clear right to debug, which is great. So that'll wipe out that one and all these previous ones. Okay, so what's happening is red is looking, he's using a PSearch on blue within this radius. He finds 98 particles. All of those found particle IDs are being pushed into a memory stack, which red is memorizing. And what we want to do is we're going to iterate through that whole memory stack and born some green particles off those blue particles. So we need the red particle because he is the one who's memorized. Red particle, let's connect him to memory, and we are going to output those 99 particles. But before we can do that, we need to tell memory which particle ID we're looking for. If we don't specify depth, it's just going to use 0, which is not what we want. We want to actually iterate through the entire range, count of 99. And we'll go ahead and specify this on. We're just going to expose that for now. And what we want to do is we want to use a generator position born we're going to born green particles, 1 per call. Let's make them go just straight up with a pretty good amount of speed. And what we'll do is we'll go ahead and connect those nearby particles to this, and we're going to take the iterator's number and feed that into depth. Okay, now you see that we're not getting the results we expected. What you have to do is we're going to have to, remember this goes back to the initiators in series versus parallel. Right now we're trying to use 2 initiators, a red group and an iterator. Can't do it in parallel. You're going to have to go ahead and take the particle, feed it into the iterators on in order to control it. And actually we'll restack this to get this a little more logical. So red, it's going to call the iterator. It's going to be iterated 99 times. That iteration, those numbers are going to be fed into the depth. So it's going to iterate through memory's depth stored particles, 0 through 98 or 99. And it's going to output each one of those into this position born. And you can see it's doing it over and over. We actually just want to go ahead and control this with a time interval to only have them give birth once. We'll go ahead and give birth at 1. So you can see each one of those blues gives birth to a green particle. And if we were to say, okay, well, let's iterate less, you can see what's happening is it's decreasing the amount of iteration that occurs. We can also actually tell by using this count where they were stored in memory. So count, this would be 0 through 9. So depth of 0 through 9 is all these particles here. And as we increase, we can see all the other ones that were included. And of course, we max out with memory operators. Capability is 99 depth, so our iterator, we might as well just leave that at 99. Okay, so iterator with memory is a way to access multiple depths of information at once.